5C is about simple interest, both in the idea of like the interest that would accumulate in a bank account, but also like the interest that would accumulate on a loan that would have to get paid back. So this formula right here, there's going to be a lot of this in this section. That's the way that you compute simple interest, where I is the interest, and it's equal to P times R times T. P is the principal amount of money, so it's the amount that you start out with. Then R is the interest rate, which computationally you're going to want that written as a decimal, which makes sense, right? All like the tax rate stuff was all written with decimals, so this is going to work the same way. And then T is the amount of time that's elapsed. The one other thing that I want to point out, because this will make a difference when we start talking about short-term loans, because they're in this section. Short-term loans tend to be in months rather than years. And everything else tends to be in years, at least what shows up here. So the rate and the time need to be in the same time units. So like if the rate is an annual rate, then when you're doing that multiplication to get the units to work out correctly, you want the time to be in years. And then if the rate is a monthly interest rate, then you want the time in months, right? So then that way, like if the units are consistent, then you'll end up where you're supposed to with the amount of interest. Then the other thing that we're going to need, because this will show up an awful lot too, the total amount of money accrued. So the reason there's an A is just for the word accrued. But the amount of money accrued is the principal plus interest. So you could write it symbolically as A equals P plus I, or you could do it by writing out what I is. So A equals P plus PRT. And a lot of times it's written like this. And this thing, that the way I wrote it, it looks like this is sort of an offhand thing to write A as P times the quantity 1 plus RT. It's not. You actually see that quite a bit. And like in business courses, that's the way it's written. It's written like that. So I'll try to work in both of them here, or I guess the different ways of writing A. So either with the P factored out or with it distributed, I guess. All right, so that first example, we have an investment of $15,000, paying 4.6% simple annual interest. I guess another thing that's worth mentioning, why does it say simple interest, not just interest? Because there's also something called compound interest, which is different, which is in the next section. But 4.6% simple annual interest, and what would be the total value of the investment after 10 years? Okay. You could do this a couple of different ways. You could go right for the amount of money accrued and do it all in one shot, or you could get the interest first and then add it to the principal. I think for the first example, that's the way that I want to go. So just to kind of use the interest formula directly and say that I is going to be equal to P times R times T, because here the 15,000, that's P, right? That's the principal amount being invested. The 4.6% is R. We just have to convert it into decimal form. And then T is over here, right? It's the 10. So we're going to end up with 15,000 times 0.046. And I guess I'll write it as 0.046. It probably looks better. Times 0.046. And then times 10. And if you multiply that out, that's going to be 6,900. All right. And so then A, the amount accrued, that's the total value of the investment, right? So this you could just view as the amount accrued, if you want to use that term. Those are the same thing. So A would be equal to P plus I. So principal plus interest. And so that'll be 15,000 plus 6,900. So that's going to be 21,900. All right, so that's getting the interest and then adding it to the principal. If you wanted to do it all in one shot, you could. So I'll do this in a different color and just say, or what if you did this? If you said because we know we eventually just want to get the amount accrued, right? That's what we're asked about. So you could do it as P times the quantity 1 plus RT and sub everything in there. You'd have 15,000 times 1 plus 0.046 times 10. So inside the parentheses, that simplifies to 1.46, right? You multiply the 0.046 times 10, you get 0.46. Add that to 1, it's 1.46. So this ends up being 15,000 times 1.46. And you do get the same thing. You'll get the 21,900. So either way will work. Whichever one seems like it makes more sense, I guess pick that one. But they'll both work. Okay. Then the next one, and the next one you got to be careful. I should do this in bright red. Because it's a short-term loan company, and with the short-term loans, everything tends to be per month instead of per year. So, got to be careful, right? All right, well then, let's see what we've got. We've got that P, the principal amount of the loan is $950, right? So we know that. So P is $950. We know that R, the interest rate, it says 9% per month. So I'm going to convert that into decimal form and say 0.09 per month. And I'm just writing out the month just to double check and make sure everything matches up, that then the time is also in months. But it is. It says it's repayable in 6 months. So then T is 6 months. All right. So then it looks like we're good to go here. We've got the rate in months, and then we've got the time in months. So they got the same units. That's the thing that we had to check for. All right, so the amount that must be repaid, that's the amount accrued. So we could do it the way that we did, I guess, the end of the last one, and say that A is equal to P times the quantity 1 plus RT. Do it like that. So then we'd have 950 times 1 plus 0.09 times 6. 0.09 times 6 is 0.54. So what you end up with inside the parentheses is 1.54. So 950 times 1.54, which is 1463. All right. And if you're looking at this one, especially if you did it the other way, like if you got the interest by itself, the interest is 0.54 times 950. It's more than half of what the loan was. And if you think, that's an awful lot for 6 months, or for the interest to accumulate that much. It is, but that's how short-term loan companies work. Right? With short-term loans, it's like if you don't pay it back right away, it just snowballs. Because the interest rate doesn't look too intense, except when you factor in that it's per month instead of per year. Right? 9% per year, that's doable. 9% per month, right? That'll build really fast if you don't pay it off right away. And so that's why after 6 months, it's over 1.5 times what Morgan actually received for the loan. So short term, right, you tend to see these things where they go crazy. So the reason I'm bringing this up, other than like that is the way that it works in real life, is also that's the way it works in the homework. And with the short term ones, you might end up doing a computation and think like, that's way too huge. If it's a short term one, it probably isn't way too huge. They tend to get big really fast. So just, I guess, be aware of that that's how they work. Let's see, then the next one. All right, so this is solving for something a little bit different. So it says Kendra's bank account earns 3.8% simple interest. How much should she deposit in the account today if she wants it to be worth $4,000 in 5 years? Okay, So one thing is notice there's no time frame with the interest. So right here it just says 3.8% simple interest. If there's no time frame, assume that it's per year. So in general, that's the way you want to do it. So if it's going to be per month, they'll tell you. But if it's per year, they might not tell you. So I kind of intentionally wrote one like this where I left it out, just so I could say this. But if there is no time frame, then assume per year rather than per month. Okay, so let's see, what do we have? We have that R is going to be 0.038 per year. And I'm going to write that out again just to make sure the time matches up. And she wants it to be worth 4,005 years. The 4,000 is not P. The 4,000 is A. It's the amount accrued, right? It's the principal invested now plus the interest that accumulates over the subsequent 5 years. So A is 4,000. And then T is 5 years. Okay, so T is in years, R is per year, good to go. Okay, then we've got that A is P times the quantity 1 plus RT. And we're solving for P because we want to know how much she should deposit right now, what her initial investment or her principal investment should be. So then we can sub in, and we'll have that 4,000 equals P times 1 plus 0.038 times 5. So inside the parentheses, that actually works out pretty well. It's 1.19. So the 0.038 times 5 will give you 0.19. And so what we're going to get is 4,000 equal to P times 1.19. And then we're solving for P, right? So we're going to divide both sides by 1.19 to get the P by itself. And so what we're going to end up with is that P is 4,000 over 1.19. And we're going to have to round, and it says to round to the nearest cent. And what you get is 3361.34 to the nearest cent. So that is our answer. All right, so with that one, same formula, but we had to solve for something different, right? Because that one, we had to solve for what the principal amount would be, and we had all the other stuff, right? We had the accrued amount, we knew the rate, we knew the time frame, and we solved for P this time. So same formula, but kind of changed up a little. All right, next thing, discounted loans. This is a similar idea, but slightly different. Because in a way it feels backwards. You'll see what I mean. So a discounted loan is one where the loan is going to be set up with some face value. And what the borrower actually gets is not the face value. They get the face value minus the interest. So what happens is the interest is calculated on the face value, and then the bank subtracts the interest out and then gives the borrower what's left. Pretty much. And that's what it says in that second bullet point, right? And so these are common for short-term loans. This isn't really a long-term loan thing, usually. And what that means, if it's short-term loans, months, right? So short-term loans, months. So there may be adjustments that you have to make. You might end up like with the rate in terms like where the rate is written per year, but then the time is in months. So you got to switch one of those things, right? You either have to change the rate to where that's per month, so then they're both in terms of months, or you change the amount of time so it's per year and they're both in terms of years. That's usually the way that you do it, is you just make them both per year, because it's more common, I think, to get a rate where if you tried to change it to where it was per month, it would look awkward. like it would be tiny and awkward. So usually you go per year. So that's how we're going to do it. We're actually going to have to do it in number 4. So in number 4, it says Imani takes out a discounted loan for $1,400 at a simple interest rate of 8% over 9 months. So remember, for the interest rate, if it doesn't say months, you got to assume that that's per year. So it's 8% per year. And the time is not set up in years, but we can fix that. So then how much money does she actually get? Because she won't get the full $1,400. She'll get $1,400 minus interest. Okay, so you still use the same formula to figure out the interest that gets subtracted out. So the P here, the principal, is the $1,400, even though that's not really an amount being invested here, that's really the face value. So I'll just put that in parentheses, that's really what that is. So it's the same formula, just a different context, right? A little bit different. R, the rate is 0.08 per year, right? Because when it doesn't specify the time, it's per year. That A looks awful. And then 9 months for the time. So T is 9 months. But then that would be 9/12 of a year, or since that fraction reduces 3/4 of a year, that's probably the best way to write it. So that's what we'll do. Okay, so then the interest, it's still going to be P times R times T. So our P is 1,400. Then our rate is 0.08. And then our time is 3/4. Or if you want to write that as a decimal, it would be 0.75, right? So I guess we can rewrite that and say this will be 1,400 times 0.08 times 0.75, and that ends up being 84. So it's $84. So then the amount deposited it's going to be the face value, so the thing that we're labeling as the principal here, the amount that you start off with, minus the interest. So here that's going to be 1,400 minus 84, which would be 1,316. So that's what it's going to be here. Right, so I guess really, and I'll just annotate this with a different color, this right here, that's really, the face value minus the interest. Since that's how discounted loans are set up. That's what the person borrowing the money will actually get. All right, so a little bit different, right? The way it's set up is different. To where it's not like you add the interest to the principal, you end up subtracting it, right? So that feels like it's reversed. And we did have to do the conversion with the time because we needed the time units to match up. So we had to change the 9 months into 3/4 of a year. But other than that, we're still using the same formula at least, so that's good. And there are a couple other examples in here where we got to use that formula that have to do with discounted loans. So number 5, all right, it says Max takes out a discounted loan for $1,000 for 15 months, receives $940. So now we know what he's getting. So there's the P minus I. So then what's the simple interest rate? Okay, so what are we being given here? We know that P is 1,000, right? Because that's the face value on the loan. And we know that P minus I, what he actually gets, is $940, right? So between those two things, it looks like I must be 60, right? Yep. So that's the amount of interest which we're going to need, right? Because we're going to end up solving for R since we're asked what the simple interest rate is. The other thing is we have the time, which is 15 months, but we're going to want to convert that into years. So that's going to be 15/12 of a year, or I guess 1.25 year, right? I guess you could write it as a mixed number. Or you could, I guess, reduce the fraction too and say that it would be 5/4. But I think we're going to put this into a calculator anyway, so it'll probably be easier as a decimal. All right, so then I equals PRT, and we're solving for R this time. All right, so we know that I is 60. P, what we started out with, our face value of the loan, that's 1,000. We don't know what R is yet, so we'll just leave that as an R. And then T is 1.25. But then on the right side, we can simplify a little bit. We could multiply the two numbers together, and 1,000 times 1.25 is 1,250. So 60 would be 1,250 times R. And then we want to get the R by itself. So let's see. Then we're going to divide both sides by 1,250. So 60 over 1,250 equals 1,250 R over 1,250. So we're going to get the R on the right side. And then on the left, when you divide that, you get 0.048. So then what that means is that R, if you write it as a percent, would be 4.8%. And that's usually the way they want the answers in the homework. I think that's the way it is every single time in Newton, that they want the rate, if you're solving for that, written as a percent, but leave the percent sign off. Oh, and if you make that mistake, don't feel bad. I did it when I was running through the homework, and I'm like, I did everything right. Why does it say it's wrong? And it's because I kept writing a percent sign. All right, and number 6. All right, so this one we're solving for T, because it's what's the duration of the loan. So that's the time frame. All right, so it says Darren takes out a discounted loan for $1,600, simple interest rate of 11%, and he receives $1,336 in his bank account. All right, so we know that P is 1,600, and he got 1,336, so that's P minus I. And then that would mean that I must be 1,600 minus 1,336, right? It's got to be the difference between those. And so that means that I must be 264. Okay. Then the other thing that we know is that R is going to be 0.11 per year, right? It doesn't specify the time frame, so it's per year. Okay, well, we know what I is, we know what P is, we know what R is, and we're supposed to solve for T. Looks like we're good to go. So I is equal to PRT. We know that I is 264, P is 1,600, R is 0.11, and then T we're trying to figure out. All right, so then 0.11 times 1,600, that's 160 plus 16, that's 176. So 264 is equal to 176 times T. And then we want to solve for T. So we would divide both sides by 176. So 264 over 176 equals 176T over 176. So we're going to get a T here. And then 264 over 176 is actually 1.5. But that's 1.5 years, because R is in terms of years. So this is 1.5 years. And if you look at the very last thing in the problem, express your final answer in months, not years. So I'm just going to point at that in a different color. So that means we got to switch, right? So I guess I'll just do this in red. So if T is 1.5 years, and we got to convert that into months, it's just 1.5 times 12, right? So that's going to be 18 months if it's a year and a half. And that is the answer. All right, I think that takes care of the first run of discounted loan stuff. There's actually another run of it here too, because the effective interest rate relates to that as well. So what the effective interest rate is it's the interest rate on the loan from the perspective of the borrower. So what we've been doing before, like in number 6, where there's a simple interest rate of 11%, or how we solved for it in number 5, and it was 4.8%, those are calculated based on the principal, right? They're based on the face value of the loan. So that's the interest rate from the perspective of the bank. The effective interest rate is, or I guess from the lender, right? It doesn't have to be a bank. Usually it's a bank, but I guess generally from the lender. The effective interest rate, on the other hand, it's the interest rate from the perspective of the borrower. It's not going to be the same because it's computed based on the amount the borrower receives. And the amount the borrower receives isn't P, it's P minus I. So it's computed based on P minus I instead of P. That means it's going to be a different rate. Because the interest itself, like the amount of interest as a dollar amount, is going to be the same. So it's got to be a different rate if you're starting, I guess, from a different point and ending up at the same point, right? Okay, so just for kind of a basic example here, if you have a discounted loan for $1,200 with a simple interest rate of 10% over 9 months. So the interest would be, so I equals PRT again, 1,200 for the principal times 0.1, and then 9 months, convert that into a year. That's 9/12 of a year, right? So then I just rewrote the 9/12 as 0.75, and it's $90. So the borrower wouldn't get the full 1,200, they'd get the 1,200 minus the interest of $90, and they'd get 1,100. So then what's the effective interest rate? Well, that's determined, at least in this case, using the 1,100 as the principal, since it's from the perspective of the borrower, right? And that's the amount that they get. And then eventually they have to pay the full 1,200. So it's already known what the interest is. It's $90. And we know that the time frame is 9 months, or in years, 0.75 of a year. So if we take the interest formula and sub in, which is this line with the arrow in it, we know I is 90. P now, if it's from the perspective of the borrower, is 1,100. And then T is still 0.75. And then we have to solve for R. So if you multiply 1,100 by 0.75 and then divide 90 by that number, what you get is not 10%. It's 10.9%, rounding to the nearest tenth of a percent. So it's bigger, but the interest rate's higher. That will happen every single time because P minus I is always less than P. And the amount of interest as a dollar amount is always the same. So if you're starting from a lower amount, but you have to get the same amount of interest, the interest rate's got to be higher to make that happen. So the effective interest rate is always going to be bigger, which is a nice thing to know because then that works like a check, right? Like if you had to compute an effective interest rate, and like if you had an algebra error and you ended up with something that was too small, right? If it was smaller than the simple interest rate, then you'd catch it and go, wait a minute, that doesn't make sense, right? So it's nice that that happens every single time because then that functions as like a check for the algebra. But the reason it happens is because from the perspective of the borrower, the principal is always going to be smaller, right? Because the simple interest has been subtracted out. So that's going to do it, and that's going to do it every single time. So at least it's nice and consistent, right? That's certainly a good thing. All right, number 7 then. It says that Sophia took out a $750 loan with a 9% simple interest rate for 8 months. So what's the effective interest rate? Okay, so first, in order to figure that out, we need to know how much she actually gets, right? How much gets deposited in her account, because that functions as the principal when you figure out the effective interest rate. So this is going to be 2 steps, really. So step 1 is that we have to determine the amount deposited in Sophia's account. So what we're going to do is we can figure out what the interest should be, and then we can subtract that out, right? Kind of like what we were just doing with the discounted loans to figure out how much people would actually receive. So what do we know so far? Well, we know the principal amount, so the face value is $750. And we know that R is going to be 0.09. And then, and that's per year, right? So per year. And then T is 8 months, but that's going to be 8/12 of a year, or if you reduce it, 2/3 of a year. So then I equals PRT, but P 750, R is 0.09, and T is 2/3. So really, the 0.09 times 2/3 is going to be 0.06, right? That's going to be 0.18 over 3. So I is going to be 750 times 0.06, which works out to be $45. So that means that Sophia receives 750 minus 45, which is 705. So that's important. 705, we need that to figure out the effective interest rate, because if it's from her perspective, that's the principal that she starts out with, and then she pays back that plus the interest later. So, all right, step 2. Here's where we'll get the effective interest rate. All right, so now in order to do this, we're going to say that P is 705. So, right, this is the part that's new, right? Because it's from the perspective of the borrower. So from Sophia's perspective, that's what she gets initially, right? And we know what the interest is. We know that it's 45. We just figured that out. And we know that the time frame is 2/3 when it's in years. Okay. Well, then we should be able to solve for R using our old war horse of a formula, I equals PRT. And if we sub in, we're going to have that 45 is 705 times R times 2/3. And it works out that 705 times 2/3 is an integer. It's 470. So 45 equals 470R. And then if we divide both sides by 470, then 45 over 470 will be equal to R. So then R roughly, and this is a part where you have to use a calculator, it's about 0.0957, or to write that as a percent, 9.57%. Which makes sense, right? It's a little bit bigger than what the simple interest rate was, just like what happened in the example on the last page. And that is also what will happen in number 8. So what you'd expect with number 8, since the simple interest rate is 7%, you'd be thinking, oh, it'll be 7 point something. And it will. But what we did in number 8, we basically have to do here. Because, I mean, other than the fact that here, the first thing we got to do is solve for the time frame instead of just figuring out how much was deposited, because we're already given that. But we're still going to have that initial big first step where we've got a missing piece before we can figure out the effective interest rate. So we've got to go get the missing piece. And in number 7, the missing piece was how much money was actually deposited in Sophia's account. Right, we got to get that first, and then we can sub it in to get the effective interest rate. Number 8, it's the time frame. We got to get that first. So a little bit different, but still pretty similar. All right, so let's see. What we got to do first is determine the length of the loan, or the time frame. So let's say determine the length of the loan, or the time frame, whatever you want to call that. All right, so what we've got, we know that P, the face value of the loan is 1,300. We know that P minus I is 1186.25. So if we have both of those, then that means that I should be 1,300 minus 1186.25. So that means that I is 113.75. So that's a piece of information that we're going to need. And then the other thing is that we know what R is. It's 7%. So R is going to be 0.07 per year. Okay, and then the thing we're supposed to be solving for is T. But we know what I is, we know what P is, we know what R is. So we've got everything else. So we should be all set for that. So if I equals PRT, and we're going to solve for T, we're going to have 113.75 equals P is 1,300, then R is 0.07, and then T for now is just T. 1,300 times 0.07 is 91. So 113.75 equals 91 times T. And if you divide both sides by 91, then T is actually 1.25. So it's 1.25 years, right? Since the rate was in years. I guess 1.25 year, I think you write it that way, when it's one and change rather than pluralizing it. Although I could be wrong about that. But once we have the time frame, then we can figure out the effective interest rate. Okay, so P is the amount that Gabriel actually gets here, right? Because it's from his perspective. So here P, the principal that he starts out with, is 1186.25. And we know that the interest is 113.75. And we know that T is 1.25. And that should be enough to put all this together, because we're just solving for R now. So we have I equals PRT, where then I is 113.75, P is 1186.25, then times R, and then times 1.25 for T. If you multiply these, and actually because these are so specific, like in the homework with the nearest 0.01%, I would try to not round off any intermediate steps. So what I would do here, because I got to multiply these numbers, and I'm going to get something that terminates after 4 places, I'm going to write out the whole thing, just because the answer has to be so specific, to the nearest 100th of a percent. So 113.75 equals, if you multiply 1186.25 and 1.25, it's 1482.8125 times R. So then that means that R would end up being 113.75 divided by that number. So divided by 1482.8125. So then R is roughly 0.0767, or converted into percent form, 7.67%. And yeah, it's what we thought, right? It's 7 point something percent. Since the simple interest rate was 7, you think, all right, well then the effective interest rate ought to be a little bit higher. It ought to be 7 point something. That's exactly what we ended up with. So 8 is a little bit different than 7 because we had to solve for something else initially in the first step. But it's still about the effective interest rate. The thing about the effective interest rate that I think is weird is that what's considered to be the principal changes, right? That's the thing that it's tough to kind of, I guess, rationalize at the very beginning, because that part feels weird if you haven't seen this before. Absolutely, that feels weird. But it's just because it's like the perspective shifts from lender to borrower. And then what does the borrower get initially? It's the face value minus the interest. And that's the way that I always remember it. It's like you shift from one side to the other, right? You go from one perspective to the other perspective. That was the way that I always like kept that straight in my head with what your principal should be to get the effective interest rate. But anyway, I think if you can do these, the effective interest rate ones, you can do everything else, right? Because if you can do these, you could do the discounted loans, because those are this concept but not as involved. And I think that would basically cover this whole section. So I think that should take care of all the variations here. I mean, I guess there could be slight differences, like maybe there's one where I don't know, you have to solve for P first, and it's an effective interest rate one, since we didn't have one like that, but it wouldn't be too much different. So hopefully that'll cover everything that'll show up in this section.